Hi everyone and welcome to Chem class. Yes, you are in my wardrobe again, but that's because I can use clothes to explain many a chemical concept. And today I want to talk to you about covalent bonding. You've probably seen the definition as being the sharing of electrons, but let's give an analogy to really make that work for us. It's different to creating an ion where something actually gains or loses an electron permanently. This is different. Everything's keeping their electrons, but they're trying to achieve some stability. So let's take the example of me being invited to 8 different functions. Yes, I know, feeling very popular at the moment. So I've got 8 different functions, and let's just say we've got the same circle of friends at each one, and I want to wear 8 different outfits. But alas, I only have 7 dresses. I don't want to go buy one, and I don't want to steal a dress off someone, so maybe I could borrow one. Let's take my sister, being in the same situation. She has 8 functions to go to and only 7 dresses. So what we decide is that each of us will borrow a dress off the other person. So together, we will both have the 8 different outfits that we're trying to achieve, as long as we share one outfit with each other. If I was modeling a different particular atom, let's say oxygen, with 6 valence electrons, again having 8 functions to go to and only 6 dresses, I'd partner up with someone that I could borrow 2 dresses this time so that I achieve the 8 dresses that I need for my 8 different functions. Let's have a look at that on paper and how we model that with our Lewis diagrams. So let's have a look at how we can represent this covalent bonding with a particular type of diagram called a Lewis diagram. There's a couple of different variations of a Lewis diagram, but ultimately the diagram needs to show bonding electrons or sharing electrons and non-sharing or non-bonding electrons. Let's take a couple of examples to model this. Let's have a look at Cl2, which you've probably already seen in examples, but let's use my analogy as well about the dresses and the outings. Chlorine, I've listed down the side here, chlorine has 7 valence electrons. For the sake of our covalent bonding and our Lewis diagrams, we're only interested in the number of valence electrons because they're the ones involved in sharing and instability. So the chlorine has 7 valence electrons. Let's think about my outfits and the outings. I've got 7 outfits. I need 8. So I want to share 1 electron with someone else or some other atom that also wants to share one. I use the example of my sister. So I'm going to use 2 different colors to represent the 2 different atoms, or myself and my sister in our outfits. So I have 1 chlorine atom, or myself, and my 1, 2, 3, 4, 5, 6, 7. You should know by now that electrons like to move around in pairs. So I'm representing them in pairs, but I have 1 that's unpaired. So I have my 7 valence electrons, and I know that that's not stable. I really want to have 8. So the other chlorine atom is going to help me out by having its own 1, 2, 3, 4, 5, 6, and its 7th one is paired up here. And what this means here, by putting our 2 electrons together, we get that pairing of electrons nice and stable. Each of these chlorines now has the 8 electrons that it needs, and we're sharing along that particular pair there. We can represent this in this particular way, or we can represent with a line, and 1 line indicates 1 pair of shared electrons. But what we still do, because it's a Lewis diagram, is we show the unpaired electrons. So if you are asked to show a Lewis diagram, please make sure you always have represented the shared electrons and the unshared electrons. Okay, so let's now look at an example that involves more sharing than the chlorine. Let's look at oxygen. And as I've noted over here, oxygen only has 6 valence electrons. So again, with this kind of situation, it would need to share 2 more electrons in order to satisfy the 8 electrons. If I draw the oxygen with its 1, 2, 3, 4, we need 5 and 6 to do the sharing this time with another oxygen atom. So, or it could be something else, but in this case, we've got another oxygen atom. So I'm going to put 5 and 6 here. We know there's another oxygen atom that also wants to share 2 electrons to satisfy its 8 because it only had 6 valence electrons. 1, 2, 3, 4, 5 and 6. Now why have I represented it that way? In the case of the chlorine, one line indicates one pair of electrons have been shared, or my one outfit I needed to borrow off someone. With oxygen, because it only has 6 valence electrons, it needs to share 2. So it needs to pair up and make 2 pairs of shared electrons. So if I was going to represent that with lines, it'd be oxygen, double line, and another oxygen. And really more correctly, we'd be representing the electrons sort of on an angle here, but we're just looking at numbers at the moment. So our oxygen has 2 pairs of electrons that are unpaired or non-bonding pairs of electrons, but then it needs to share 2 more because it only had 6 and needed 2 more. So it needs to give its 2 electrons energy to another oxygen as well as get the energy of the other 2 from the other oxygen. So it's making a double bond there. So let's look at one last example. This time I've got a combination of 2 different atoms that are doing electron sharing, as opposed to these 2 cases where it's identical atom types. So I've got phosphorus now, which you see it only has 5 valence electrons, which means it needs to share 3 others. And in this particular compound, there are 3 chlorines, and we know that chlorine only needs to share 1 more. So it satisfies the energy requirements of both the atoms. Well, what does that look like? So the phosphorus, we know it has 5 valence electrons. It needs to share 3 more. Maybe let's draw in the 3 that need to do some sharing. I'm going to space them out because we know that there are 3 chlorines that each want to share 1. So if I put my chlorine here with its 1, 2, 3, 4, 5, 6, 7. The 1 from this chlorine, 1, 2, 3, 4, 5, 6, 7. The 1 from this chlorine. Okay, back to my blue, which is my phosphorus. 1, 2, 3. It has 1 pair of electrons that are not involved in sharing. So we can see that the chlorine gets its 8th one from the phosphorus, this chlorine gets the 8th one from the phosphorus, and this one, and the phosphorus gets the 3 extras that it needs from the chlorine. If I draw that as a one with lines, I would represent it this way. I'd have to put in my 1, 2, and all my non-bonding electrons. Okay, I hope that helps.